Dear student, today I shall derive the time-independent Schrodinger wave equation. Now, we know from the de Broglie, that is de Broglie hypothesis, that is the subatomic particles such as electron has a wave property in motion. For example, suppose this is the nucleus and electrons are moving around the nucleus. Now, when electron moves, it possesses wave property. That is called matter wave. Now Schrodinger formulated a wave equation for this electron wave, which is known as Schrodinger wave equation. Now Schrodinger considered that, he proposed that motion of electron in an atom, more accurately, wave motion of electron in an atom is similar to that of stationary wave, such as vibrating string whose both ends are fixed. Now, by considering this idea, he developed an equation, that is formulated an equation which is known as Schrodinger wave equation. Now, the general wave equation in one dimension is given by the general wave equation in one direction, that is one dimension, say x-axis, is given by del square psi by del x square equal to 1 by u square del square psi by del t square. This is the equation number 1. So this is the general wave equation in one direction. For three direction, that is all dimension, just we have to add two more term, that is y and z. So this is the wave equation in one dimension. Now what is the psi? Psi is the amplitude function. That is, psi is amplitude function, also called wave function, And what is the u? U is the velocity of the wave. T is the time. If the velocity u is independent of time t, I repeat, if the u, that is velocity of the wave, is independent of time t, then this psi can be expressed as a product of two functions. That is, the psi can be written as a product of two functions. One function is depend on space coordinate, that is x, y, z, and another function depends on the time. That is, if u is independent of t, then psi is a function of, one is space, that is, since it's one direction, one depends upon x, and another function is depends on t, which is the two function. One function is a product of two function. One function depends on x, another function depends on t. That is, psi can be written as a product of two functions. Now putting this value of psi in the equation 1, we get the equation number 2. So putting this value of psi in the equation 1, we get, putting the value of psi in the in the equation 1, we get del square upon dx square psi is of psi x exponential I 2 pi nu t. This is just this is the value of psi equal to 1 by u square, again del square upon del t square, again to put the value of psi, that is put the value of psi is psi x exponential I 2 pi nu t. Just we have put the values of psi in these equations. Now we have to do some mathematics here. Simple double differentiation. Now you see the two function, this function and this function. This function is independent of x, but this function is dependent on x. So since there is no x is independent of x, so this is regarded as a constant quantity. So it is come out of the differentiation. Similarly here also, so this portion is depends on t. This is independent of t. So this portion comes out of the differentiation as a constant quantity. So we'll write. So which one is constant quantity here? This is the constant quantity. So we can write, or e exponential I 2 pi nu t. This is come out of the differentiation. Del square psi x upon del x square equal to 1 by u square, 1 by square. Like which one is the constant quantity? Del x, psi x is the del x constant quantity. Psi x is a constant quantity out of the differentiation. Now this differentiation should be done twice. So after differentiation it will come, this come twice, two portions, that is except t, that is I 2 pi nu 2 pi nu square, and the function itself exp I 2 pi nu t. So this is the results of this double differentiation. Now this quantity and this quantity cancel. Now what left now? Or del square psi x by del x square equal to 1 by u square. So we can write directly, we can write directly. So I square equal to minus 1, so it's minus 4 pi square mu square by u square psi x. So equation number 3. Again we know u equal to lambda nu. E equal to lambda nu. Now putting the values of u, in this equation 3 we get del square psi x upon del x square equal to minus 4 pi square nu square. Now u square equal to, that is lambda square and nu square psi x. Now this is cancel, or we get del square psi x by del x square equal to minus 4 pi square lambda square psi x. Now from de Broglie relationship, we get lambda equal to h by p. Lambda equal to h by p. So putting this value lambda, that is h by, we shall get here, we can write, that is, say equation number 4, equation number 5. So from the equation from the equation 4 and 5, from the equation 4 and 5, we get del square psi x by del x square equal to minus, putting the values lambda from the equation 5, we get 4 pi square, p will go up, that is p square by h square psi x, equation number 6. Now the total energy of the electron, energy E, equal to, we know it is the kinetic energy plus potential energy. Total energy is kinetic energy plus potential energy. So what is the kinetic energy? Half m v square. Say potential energy, say regarded as v. Potential energy is a v. Now we can write this quantity by, say, m square v square twice m plus v. That is, we can write, that is mvp, p square by twice m plus v, or p square equal to, we can write from this equation, p square equal to say p square equal to E minus v into twice m. Say equation number 7. Now putting the value of p square in the equation 6, this is a p square value. Putting the value of p square, say from the equations 6 and 7, we get, that is putting the values of p square in the equation 6, we get del square psi x by del x square equal to minus 4 pi square, putting the value of 4 pi h square. What is the value of p square? P square is a, say, twice m e minus v x psi x. So we get del square psi x by del x square equal to minus 8 pi square m by h square psi x, or 8 pi e minus v psi x, or we can write del square psi x upon del x square plus 8 pi square m h square e minus v psi x equal to 0, which is the Schrodinger wave equation in one direction. That is, which is the wave equation, Schrodinger wave equation in one dimension, which is Schrodinger wave equation in one dimension. That is one dimension. Now for three dimension, just we replace this quantity by x, y and z. Now for three dimension, or for three direction, for three dimension, for say 3D, we can, for three dimension we can write del square psi x y del say x square. So we can now plus del square psi by del y square plus del square psi by del z square equal to plus 8 pi square m by h square e minus v psi xyz. Here psi is now depend on x y, that is psi x y z. We can write like this. Here psi x y z, psi x y z, psi x y z. So psi equal to 0, which is Schrodinger wave equation in 3 dimension. Now let us take psi common. We will get, so this is our purpose is here up to this, that is derivation of Schrodinger wave equation we have derived successfully. So we can write more. Now psi common, say del x square plus y square z square, this is common. Psi equal to, not equal to, sorry, plus 8 pi square m h square e minus v psi equal to 0. Now this quantity is a Laplacian operator, Laplacian. So it is written as like this. Read as del square psi equal to plus 8 pi square m h square e minus v psi equal to 0. This is almost same. Now this is a equation number I think most probably 8 equation. Now multiplying equation 8 by multiplying equation 8 by minus, that is reverse of it, h square 8 pi square m. H is h square 8 pi square. We get, let's see what we get. We get, let's multiply it. Minus h square 8 pi square m del square psi. Now this is cancelled. There will be minus e minus v psi equal to 0. Now, or separated h square 8 pi square m del square psi. This is minus minus plus. So v psi. So v psi equal to, this is e psi, goes to right side is with e psi. Now, or minus h square 8 pi square m del square plus v psi equal to e psi. Or we can write, this is h cap, this is this quantity is called Hamiltonian operator, denoted as h cap psi equal to e psi, where this quantity is called Hamiltonian operator, which is the Schrodinger wave equation in operator form. Schrodinger equation in operator form. So we have successfully derived the Schrodinger wave equation one dimension and extended to three dimension, and also Schrodinger wave equation in operator form. So thank you for watching this video.